Over 1 billion people are holding one. They capture their memories on it. The iPhone is the most profitable product in history. Today, an iPhone is, at its core, a transformation of the Earth itself. Sand becomes silicon. Regards its process. Suppliers sign strict NDAs. Massive penalties face them. Workers operate in the dark. Engineers don't see the full picture. The iPhone's brain begins not in a laboratory, in silica sand quarries stretching across the globe. This sand is 60% silicon dioxide. Raw silica sand is only 25% pure silicon. It is heated to 3,200 degrees. This leaves metallurgical. Hyperpure polysilicon is melted. Over 24 hours, a perfect crystal cylinder is slowly pulled. Your iPhone contains 17 different elements. Cobalt from the Congo powers the battery. Neodymium from China creates the magnetic field. Cobalt is critical for batteries. Raw ore is dissolved in acid. This produces over 99% purity. Bauxite rock is mined in Australia. Electrolysis creates liquid aluminum. Magnesium and silicon create aerospace aluminum. A single iPhone contains 15 grams of copper. Chile's Atacama Desert produces 28%. Smelted copper is drawn into wire. The ceramic shield glass starts here. High-purity sand is melted at 2,800 degrees. It flows onto a bath of molten tin. Apple partnered with Corning to create glass with ceramic crystals grown inside it. Nanoscale crystals nucleate throughout the matrix to block cracks. No single country builds an iPhone. Apple's supply chain spans 43 countries. Every component converges on a single. The most valuable cargo on Earth travels by air. TSMC's A18 Pro chips are transported from Taiwan to China. Not all components travel by air. Bulk system, before being dispatched by truck, arriving at Foxconn. Welcome to iPhone City. This facility is an entire city. Here, hundreds of thousands of workers live and work. The Foxconn receiving dock processes over 300 truck deliveries every single day. Every incoming pallet is instantly logged. Every batch passes inspection. Engineers measure chip electrical parameters, display color accuracy, and aluminum alloy composition. OLED displays are stored in nitrogen-purged enclosures. Battery cells are kept at precisely 15 at controlled humidity. Orchestrating this requires AI. Foxconn's system processes millions of data points, adjusting lines to maximize throughput. 3 hours flight from Foxconn in Taiwan, the A18 Pro chip begins its life at TSMC Fab 18, the most technologically advanced manufacturing. This machine costs $150 million, creating light by firing a laser at tin droplets 50,000 times per second, generating. It is a 3D architecture, built layer by layer, like a microscopic skyscraper. Over 100 individual layers are. Etching removes material to create circuit structures. Plasma etching uses fluorine ions with atomic precision. Every A18 Pro chip is tested. Probes run 10,000 tests in milliseconds. Failed chips are marked red. Only green chips.
Known good chips are cut from the wafer. They are bonded face down in a process called flip chip packaging. Underfill epoxy fills the gap. Finally,
the display you stare at was born in Samsung's Asan facility. Here, organic layers are deposited in vacuum chambers. This creates. OLEDs are sensitive to moisture. Promotion uses low-temperature silicon. A thin glass and polymer stack seals the layers. Large mother glass panels are laser cut. Every display is individually color calibrated. A spectrophotometer measures color response. Apple's main camera sensor is manufactured by Sony in Japan. This 48-megapixel sensor uses a backside illuminated design. The iPhone 16 Pro main camera contains a 7-element optical lens system. Each lens element is ground to nanometer surface accuracy. These elements are.
Apple's LiDAR scanner fires infrared pulses. It detects returning photons, building a precise 3D map.
The chassis begins as a solid block. A 5-axis CNC center removes 80% of that material, leaving it accurate to 0. After machining, the iPhone chassis receives its distinctive surface texture. Automated brushing machines create the uniform satin finish. Camera rings, colors are grown into the metal. Current creates a porous layer. Dye molecules flood these pores. Heat seals them permanently into the aluminum. Laser drilling creates each speaker hole, measuring exactly 0.4 millimeters. Acoustic models optimize the pattern, verified for perfect sound. Laser cut to exact dimensions, the perimeter is ground to a curved profile. Submerged in a chemical bath, potassium ions create a compression layer that final assembly takes place across dozens of parallel production lines. At peak production, an iPhone is completed every 3 seconds. This SMT lines provide pure automation. Prorated solder goes on 1,200 pads. It places 50,000 parts an hour, true to 25 microns. Hidden joints cannot be inspected visually. X-ray systems examine every board, creating 3D images to detect any voids or bridging. The iPhone battery is positioned. A robotic arm acts with 0.1 millimeter accuracy. Adhesive strips both secure and enable future removal. Inside, the Taptic engine creates precisely controlled frequencies. Calibration software verifies each intensity at 3 defined levels. These screws are driven to exactly 0.9 Newton-meters of torque by calibrated automated screwdrivers. The torque is verified for every unit. Every iPhone receives its brain here. iOS is installed via Apple's secure installation system, and the frameworks. The iPhone is alive. Every iPhone undergoes over 100 automated tests. Robotic pneumatic fingers verify touch response. Precision audio systems measure frequency response. And Apple tests for years from now. Chambers cycle iPhones through extreme temperature ranges. Conditions simulate years of real-world use in hours. Quality inspection combines human eyes with machine vision. Humans detect surface defects holistically, while machines detect deviations as small as ceramic shield was developed to solve the most common cause of damage. Apple's drop test machines simulate thousands of real-world fall scenarios. Each IP68 certification requires 30 minutes at 6 meters. Electronic monitoring tracks seal integrity. Any failure, every iPhone undergoes a 45-minute evaluation. Panel gaps are verified, every button is pressed, and diagnostics run. Only every iPhone receives its permanent identity here. A laser engraves the IMEI. Apple's global database records the complete history. Apple's packaging is itself an engineered product. This white box is 99% almost all plastic. Paperboard comes sustainably managed forests. Even the iPhone is placed by a robotic arm. It contacts only the aluminum sides. Precise force limitations prevent any marks. Separate module. That box opening friction is not accidental. It is a precise 3-second experience. Shrink film is applied with a laser-marked code. From the assembly line, finished iPhones travel directly to the adjacent Apple distribution warehouse. Here, AI powered each unit based on its destination. iPhones travel exclusively by air. Apple pays $8 per unit. A full 74/7 carries 100,000. The 12
Experience absolute clarity.
Apple stores receive iPhone deliveries. Contents are kept confidential to prevent theft. Each unit is scanned into inventory and secured in a locked storage area. Now, iPhone launch day is unlike any event. Customers line up for 24 hours. Being first matters to them. The doors open. The energy is electric. Apple engineered a 3-second slide to create anticipation. The unboxing is the opening act. This is design serving emotion.
Every day, from morning alarms to connecting with loved ones, navigating busy streets, capturing memories, finding our way, and in emergencies,
The scale of what you just witnessed is almost incomprehensible. 232 million iPhones produced per year. While millions unwrap this year's iPhone, Apple's teams are already generations ahead, in relentless pursuit of the most personal computer ever created. Carries the ambition of 10,000 engineers, all to fit in your pocket.
subscribe